Good morning, good afternoon, good evening. This is Brian from H3 Platform. H3 Platform has developed a lot of PCIe chassis in the past few years. And now that we are launching a very innovative product, the sharing NVMe SSD in PCIe fabric. Some people call it NVMe MR-IOV solutions. Before I go to the agenda, I want to let you know if you have any questions, please feel free to type on the questions. I'll answer that during the presentation. If not, I will answer at the end of the presentations. So let's start today's agenda. Today we will talk about the system architectures, and then we talk about how you create virtual functions, assign the virtual function, then attach the namespace or detach the namespace. We will show you the testing result, performance testing result in the PCIe fabric, and talk about the key benefit of NVMe in sharing in PCIe fabric. Okay, the whole idea of the NVMe sharing solution is that the NVMe chassis is connected to multiple hosts. The host will be like 2 hosts, 4 hosts, or 8 hosts through the PCIe Gen 4 NVMe HD cable. The NVMe SSD in the NVMe chassis could be assigned or could be shared by the host. Let's go to some of the detail. So from the host point of view, what he will see? The CPU will see that there is a local SSD being plugged in if you assign a namespace to the virtual functions. So the virtual function itself here looks like it's an NVMe SSD controller. And then the namespace, of course, is SSD. So we attach the namespace to the virtual functions. It looks like it's a local SSD in the host side. So in total, that's a 256 VF and 256 namespace in this NVMe chassis. Let's go to see the whole architectures, what component involved in these solutions. There is a program PCIe Gen 4 switch and bounding the host, connect the host and the NVMe SSD. So there's an adapter put on the PCIe bus of the host, then go to the NVMe HD running on PCIe Gen 4 protocol, and then to the program switch. Then there's some VF on the NVMe SSD, and then there's a namespace attached to the VF, so host can see it. And how to control which VF or which namespace could be used by which host is go through the management path. The management path is like we provide a GUI, so it goes through the gigabit Ethernet port, management port, and then go to the program switch to decide which VF belong to which host. So this is the control path. Let's go to some of the detail. So the data path is like I just explained it. Data path go through the PCIe or the PCIe in-band for the host to go to the PCIe, to the program switch, to the VF, and to the namespace, all are in the in-band. And the management path goes through the 1 gigabit Ethernet port of the BMC. Then BMC talk to the PCIe switch. Then the PCIe switch, the PF on the PCIe switch doing the VF reassignment or reassignments, namespace creation, namespace rewrite configurations, and the namespace attached to VF. The management that we provide, we have 2 different ways that you can manage this kind of configurations. The first one, of course, is a GUI, management GUI. And then the other is, you see that we have a RESTful API. Let me show it to you. we have API to be integrated on the data center, because I know that in data centers, lots of people not really use GUI, but instead they use the API to integrate with their existing management architectures. Okay, so let's see the chassis itself. The chassis is 5208. And on the left side, then you have a redundant power, 1,200 watts. And here you have 8 mini-SAS HD connector. Each connector means a PCIe Gen 4 by 4. So you have 8, so it's by 4 times 8. So you total have a 32 by 4 length for the host. So you can configure as 2 by 16, 4 by 8, or 8 by 4 for 2 hosts, 4 hosts, or 8 hosts. And then the management port goes through this gigabit Ethernet port to the BMC and then to the Broadcom switch. This is the NVMe drawer. This drawer you have 8 NVMe 18 card in it. So this is the NVMe pooling to be shared among the host. Okay, now we are going to talk about a demo, how we set up the demo today. The demo is that we have 2 empty servers. There's a host adapter plane, and then there's a PCIe cables connected to the PCIe chassis. There are 3 Samsung 7035 SSD being put into the chassis. We have the this is a logical view. This is a logical view. The logical view is that you have 3 SSD in the chassis, right? So each SSD have a 32 virtual functions. So it looks like there are 32 SSD controllers in it. And then we have a pre-assigned 16 VF to the host 1 and 16 VF to the host 2. So in total, 3 SSD times 16. So you have 48 pre-assigned virtual function for the host 1 and 48 pre-assigned virtual function to host 2. And then when we attached namespace 1 to the VF1, then you will see the namespace 1 on the host 1 because the VF1 has been assigned to the host 1. So host 1 can see it as its local SSD. So what do? We will, in the demo, we will create a shared namespace 3 teras on the SSD 3, and then assign to 2 different hosts. It's a same namespace to 2 hosts, so it's a VF1 and a VF17. VF1 to the host 1, VF17 to the host 2. And then we create 2 private namespace on the NVMe SSD 6. The namespace 1 assigned to the VF2, namespace 2 assigned to VF18. So this is a private namespace to the host 1 and the host 2. Okay, let's go to see the demo. The demo that we have is a pre-recording, but we do have the remote site to let our customers to look at. So if you are interested in seeing the real systems, please feel free to let us know, that we will give you the access of the systems. This is a GUI of the system. So you will see the host view. Then you see 2 hosts. Each host has been assigned 48 virtual functions. And there's this is the total capacity. If there's a namespace being attached, they will show the total capacity. But now there's no any namespace being assigned, so there's no capacity here. And now we have SS3, 6, and 8. Each have 32 virtual functions, and have been create 1 namespace, 2 namespace, and 5 namespace. The one namespace is 3 tera, and two namespace is in total 3 tera. But later, if you go to the SSD 6, you can see what's the namespace being created. Okay, so let's go to see. This is the host view, the host 1 and the host 2. This one is host 1, this one is host 2. So on host 1, you see 48 controller. Host 2 is the same, 49, sorry. The reason is one more is because of the there's a local Samsung 90 Pro, the local SSD for the OS. So if you see the NVMe list, you see there's a one NVMe SSD. So 49 controllers, but only one with the namespace. That one is the local SSD. Okay, there's a annoying namespace being attached to the virtual function. Now we are going to attach the shared namespace to the host 1 and host 2. So we go back to the configurations page, click it to go to the config. Okay, so you see the namespace itself is not attached. So it's a 3 terabyte, and it's shared the namespace. And you see that serial number is 141. Let's later on you will see from the host 1, you will see the serial number of the SSD is 141, coming from the 141. Okay, if you click attached, you can attach. You see there's a VFID and also the host. Which VFID connects to which host? So we choose VF1 and VF17 to the host 1 and host 2. So click OK. Then this namespace been attached to the host 1 and host 2 through the VF1 and VF17. So let's go to see the NVMe list. In the host 1, but we should see that's a 3 tera. Okay, you see the 3 tera is coming from 141 NVMe SSD. And then we go to the host 2, we also see the 3 teras namespace. I want to emphasize that these two hosts see the same 3 tera namespace. So it means that you can go to the same namespace to access the same data. Okay, so now we go back to configure another namespace. We choose SSD 6, and I remind you that we will assign 2 private namespace, one to host 1, another one to the host 2. So you see that's not attached. It's a 1 tera and 2 teras. It's all are private, so you only can assign to one host. Serial number is 149. Okay, so let's go to see the attached. So you attach to the VF2 to the host 1, then click yes. And then you will attach to the host 1. Okay, so that 1 terabyte is private, being attached to the host 1. And then we go to attach the 2 terabyte to the host 2. And we choose VF18. So it's been assigned to that. So click yes, then it's been assigned to the host 2. So all these things are the hot plug. It's you just add the space to the VF. So then on the VF, then you can the namespace will be scanned, and then you will see it. Okay, you see that it's a 1 tera being assigned, 149. So 1 tera being assigned to the host 1. So there's 149, 2 tera should be assigned to host 2. Okay, so you see it's 149, 2 tera has been assigned to host 2. So both this 1 tera or 2 tera are the private namespace, could not be shared among others. Now we are going to do the FIO test. The FIO test, then we will do the 3 tera first. And from the 2 hosts, it means that we access the shared namespace from host 1 and host 2 at the same time. Then we can see the performance, whether the 2 VF performance, what's the performance that we get from 2 virtual functions. I think it should be two virtual functions should be similar to the one physical function. He can get the most of the SSD. So this SSD is a Samsung 1735. The IOPS, the spec IOPS is a 1.5 million. If you run it at 4K, so you should get around like 6,000 megabyte per second. So let's see that whether we can get a 1.5 million IOPS and the 6,000 throughput from SSD 3 and the two hosts, host 1, host 2, access to the 3 TB namespace at the same time. Okay, you see the 32 controllers, namespace 1 is the 3 TB shared namespace. This one is the same. Okay, let's go. And so we from the host 1, we got around like 3,100 megabytes. So it's around 780K. And on the host 2, that we got a 2,900 megabyte roughly. And you got around 750K. So it's around like 1.5, 1.52 or 53 IOPS from this the MSSD. So it's sent as the spec. It's a little bit higher than the spec. The spec is a 1.5 million. So it's a 1.53 million IOPS. And in total aggregate is 6,000 megabyte per second. So it's almost half. Host 1 get a little bit higher than host 2, but it's within the margins. Okay. Now we are going to do the FIO test for the SSD 6. So host 1 will access its own private namespace. It's a namespace 16 and 1. It's a VF16 and the namespace 1. And then here is the we in the host 1 we also do the private namespace. So it's 18 and 1 controller 18 namespace 1. Then we will do the both private namespace from two different hosts, and to see whether we can get the same result as what we expect. So it should be have 1.5 million IOPS in total, and also the 6,000 megabyte per second. So host 1 get around like 790s, and host 2 get 730 or 40s. So it's around like 1.52 million IOPS. It's the same as the previous one, so it's slightly higher than the spec that Samsung claimed. Okay, so it's equally have the same throughput and IOPS. Okay, now we stop that. Now we are going to see to assign the new namespace in to the. So let's go back to the configuration page. We'll use the SSD 8 to create a new namespace. We are not using the existing namespace. They already have 5 not attached, I mean available namespace, but now we will create the new namespace. So there's the serial number is 213. Okay, we create a namespace. So it means that we slice the new namespace from the available SSD. So there's a 1.7 terabytes available. We create 700 gigs. So it's 1 terabyte available space left. Okay, you can see that total availables is only like 1 terabyte left. Okay. So now we modify this property that we modify is private to the share. It's a default, it should be private. And then if you change to the share, then you click OK, then to be shared namespace. And then If it's a shared namespace, it means that it can be assigned to the multiple virtual functions. It's been accessed by multiple controllers. Okay, so we assign to number 3 host. I mean, number 3 is a VF to host 1, and then number 19 VF to the host 2. So it's been a shared namespace, 700 gig shared namespace. Okay, so when you click it, attached to the 2 virtual functions. So here we should see it from the main list. Okay, you see it? It's a 700 gigs from like 213. And the other one should be also see the same 700 gigs shared namespace from 213. Okay, you see that on the top is 213 and 700 gig namespace being added to the host 2. Okay, so this is very flexible. You can edit, and the host will get it. You don't need to shut it down or do anything. You just get it. It's the driver will find it, and driver will scan. Driver will initialize the namespace. Now we want to detach the 700 gigs from the host. So we detach that from the virtual function, then the host won't see it. Okay, it's been detached. So when you don't need it, you will be detached and then go back to the NVMe SSD pooling. So it will become available space. Okay, so that 400 gig is gone. 700 gigs is gone. So there's no 700 gigs namespace in it. Okay, this is the first part of demos. The second part of demo that what we will do is that we will in this host one that we already have the 2 virtual machines being installed, and now we will log into the data root to enable the 2 virtual machines, and we will pass the 3 teras namespace from the host to the virtual function, to the VM. And then we will do the FIO test from the VM to see what performance that we can get. Because with the virtual functions, if you assign to the VM, it's a bypass the hypervisor, so it will be very good that to get the performance. Okay, so we use Ubuntu's, we enable the Ubuntu's 2004. And so let's enable it. And then later we will detach the host 3 teras, then assign the 3 teras to the virtual machines. And then the virtual machine should see it. Okay, so enable the, let's start the virtual machines. Okay, so we will check is there any SSD? There's no any SSD. So you see the PCIe tree, there's no any SSD, and every list there's no any controllers. Now let's go back to the host. So we will give the 3 teras namespace to these virtual machines. Okay, so it's find the VFIO. And then get every list. Then you see that 3 teras has been removed from the host. And then we will let this one attached to the virtual machines. So now it's attached device to the virtual machine. Okay. So then the virtual machine should see this 3 teras being attached to the virtual machine. So let's go to see the main list. Okay, let's see the PCIe tree first. You see there's a Samsung Electronics controllers in it. So this this is the virtual functions of the there are 3 teras namespace. Okay, it's been assigned, been invited. So he found that one 3 teras namespace from a host to the virtual machines. Now we are going to do the FIO test in the virtual machine to see what performance level we can get. Okay, so while doing this test, I just want to remind you that all these things is all online, and we can easily create namespace, attach the namespace to VF, and then the VF already been assigned to the host, so the host can see it. Everything is online, so it's very flexible. Okay, so we see that you got the throughput is around 8,200 megabyte per second. It's bigger because that it's the spec of the 1735 should reach 8,000 megabyte per second, but it should be like 128K or 64K. It can reach that performance. So you from the VM you can see it reached the spec. Okay. So now that you still see that 3 teras namespace there. Okay, now we go to the host. We will get that 3 teras namespace back to the host. So it means that you don't need to do any. You can switch to the VM and switch back if the VM do not need the namespace. Okay, so it should be detached. So if you do the PCIe, then the sensor SSD is gone, and then there's no NVMe list on the VM. So it should come back to the host side. So let's see how many SSD host got. So that's 3 tera, not yet. So let's find it back to the host. Yeah, let's find it. So you will see the NVMe list again. So the 3 tera will come back. So that's very easy to assign the SSD namespace to the virtual function. The virtual function get the native performance of the other one, like a pass-through. Okay. This is a demo. Any questions? Any questions? So we demo the how you attach the namespace to the VM on the host, and how you attach the namespace to the virtual machines and run the FIO test. Everything is as expected. Okay. So now what we got? The result that under the 200. This slide is the Rocky V2's performance, and this is the PCIe fabric. So under the 200 microseconds, Rocky V2 roughly get like 1 million IOPS. In PCIe fabric, 200 microseconds, he can reach 3.3 million IOPS. So it's a 230% more IOPS at 200 seconds. And then again, it's a 400 seconds, 400 microseconds, he have 68 more IOPS. So the PCIe fabrics deliver much better IOPS and the latencies compared to the NVMe over fabric Rocky V2. So now we are talking about a key benefit. I think we have the first key benefit is extreme performance. The PCIe fabric is only 0.0 microsecond compared to other very popular fabric like Rocky V2 is 11.7. I mean over TCP 100 microseconds. NVMe over fiber channel, 150 microseconds. So it's 10 times to 100 times of the latency. So it's the NVMe, the PCIe fabric will be the lowest among all the fabric. And then in the 32 PCIe Gen 4 lane, you can deliver 48 gigabyte per second throughput and 12 million IOPS. Why is PCIe so quick? Because PCIe is from the host, you go to the PCIe and PCIe switch and the PCIe and the NVMe SSD. There's no any protocol change. So you don't need to change the protocol to some protocol and then come back to the PCIe NVMe protocol. So it will be very low latency. It's the current most of NVMe SSD is around like in the media size flash is around 60 microseconds to 80 microseconds, and the Intel Atom is 10 microseconds. If you talk about 10 microseconds, the fabric will deliver 11.7 microseconds. So Rocky fabrics already accounted for over 50% of the end-to-end latency. But in our PCIe fabric, it's only 0.7 microseconds. So it's less than 10% of the microseconds that is accounted for the fabric. If there's a future phase changed memory being used as the NVMe storage, so there's only 2 microseconds. If you have 2 microseconds medias, 11.7 fabric will account for over 80% latency. So it will become a big problem. And then PCIe only account for less than 25% of the end-to-end latency. So PCIe's fabric is future-proof as the NVMe technology evolved. The second benefit is the security. As we just showed it to you, the VF being assigned to the host and the namespace attached to the VF. So it means that all the hosts can access their own assigned VF and assigned namespace. They cannot access any other VF or any other namespace. And how about a PF? PF is in a separate network and being installed on the program PCIe switch. And then in this SoC, there's no file systems. So the data on the namespace could not be accessed or could not be read by the PF. So data will be very safe. So this is a security. The third one is a lower total cost of ownerships. On the right side, this is the Intel's SPDK. When you use a 6-core CPU for the storage service, you will deliver like 5.6 million IOPS, similar to what we have in one PCIe Gen 4 by 16. But in ours, the data is sent from NVMe controller without using any CPU. So we do not have any CPU cost. The second thing is that because of the latency is very low, it's way low, 10 times lower compared to other fabrics. So the system will have a higher utilization rate. The IO wait will be IO wait time will be very low, and the response will be very quick. So there's a lower total cost of ownerships. The fourth benefit is the flexibility. The SSD could be sliced into a smaller namespace and attached to the virtual functions and on demand for the host. When the host no longer need the namespace, it could detach and then give the namespace back to the NVMe pool. So it's very flexible that you can add Namespace, add NVMe SSD to the host, and remove from the host. And in total, in the NVMe pool, you can have a 256 NVMe virtual function. It means that you have 256 NVMe controllers and a 256 NVMe namespace. Okay. So if you want to see more information, please go to check our website or go to see our videos, or you can go to download the documents from our website. Any questions? Okay, I see one question about the availability and the demo systems. So I think it's available is now, and the demo system we will set it up remotely. If you want to play this systems, we will provide you 2 hosts and few SSD, probably like 2 or 3 SSD in one chassis. So you can assign or reassign the VF and attach the namespace to the VF to see the sharing performance by yourself. If you have this requirement, please feel free to drop us an emails. Then we will set up for you. Okay. Any other questions? Okay, if not, thank you very much for joining us this webinar. And goodbye. Have a good day. Bye bye.